Welcome to the Day 1 and Beyond hands-on series. Today's demo will be build an AI chatbot engine with Oracle Database 23 AI and OCI Generative AI Services. Let's get started. Pulling up our live labs, we're going to go ahead and click the green Start button, followed by Run on Live Labs Sandbox, and then consent to receive emails and submit. It should come back with a green check and say reservation submitted. And you can see there we have build an AI chatbot engine with Oracle Database 23 AI and OCI Generative AI Services pending creation.
After about 20 minutes, your sandbox environment will be provisioned. In order to access it, click Launch Workshop. At the bottom here, we have a set of instructions, and in the top left, we'll be able to view login info. For this workshop, we're primarily going to be using this Jupyter Lab link, so go ahead and open it. Go back to your workshop to get the password. From here, we're going to click the terminal, and then go ahead and input that first command. Type yes, and hit enter. Next, we're going to go ahead and connect to our database. Now, we already have the latest Oracle Database 23 AI installed in this lab image, but we do need to do a few things to set up first. So once you've connected, go ahead and change your container to the free PDB1 container. And next, what we're going to do is create 3 table spaces. The first here is a big file table space with the name big TBS F2 data file. It's of 1 GB size and will auto resize by 32 megabyte segments without cap automatically as long as there is free space. Our second is the undo table space with the name undo TBS 2A database file of 1 GB size that will not overwrite unexpired undo when space is low. This is what retention guarantee is. Now, our final tablespace is the temporary tablespace named temp02 database file of size 1 GB and follows a similar auto resize to big tablespace, except all extents will be the same size, which can be seen on uniform size 1M. Next, we'll create our user for our vector operations and then grant the database developer role to that user. Next, we're going to go ahead and exit. Now what we have to do is allocate memory for the in-memory vector index. So connecting again to our database, using the server parameter file, we're going to create a parameter file. And then we're going to change the memory size of only the server parameter file to 512. We're going to follow that up by restarting it immediately. Once it's shut down, we're going to start it up. And from there, we're going to confirm the vector memory size has changed. And you can see it has, big integer 512. With that, we've set up our development environment, and we'll move on to our first Gen AI lab. Following up with Lab 2, Generate Vector Embeddings. In this lab, we will load text files from a local folder, split them into segments, and then create embeddings and ingest them into the Oracle 23 AI vector database through utilization of traditional RAG methods, loading and parsing a text FAQ from a file, segmenting it, generating embeddings, and calculating chunk question similarities. This will subsequently feed the top segments to an LLM prompt with the user's question crafting a response. So getting started, I'm going to download the sample file from the link and then drag and drop it. Next, we'll right-click, do New Notebook. We want to do Python 3 kernel, so hit Select. And then just for hygiene, we're going to go ahead and rename this to vectorization. So what this function does is open all the text files in a specified folder, read them, split the content using the equal sign separator, and will then put all the resulting chunks in an array. So once you paste it, Shift Enter. Then we're going to call our function with our data. And then the final step. Now, the final step is preparing the source data to arrange it in the dictionary in a way that is easy for the vector database to digest. And then we'll sample the resulting data. So as you can see, for each chunk, we prepend the name of the source file to the text content. In our case, that's here, FAQ bar. Now this is a very simple way to ensure that some context is preserved within each chunk and vectorized later. It will be tremendously helpful in the retrieval stage when our vector distances will be calculated between the question and each chunk. Task 2, we're going to load the FAQ chunks into the vector database. So we're going to start by adding some connection details and connecting to the database. Now we just need to create the table inside of our database to store our vectors and metadata. Our final step is to vectorize the text chunks. In order to do so, we're going to start by importing an encoder to handle the vectorization for us. Ignoring those warnings, we're going to go through all of our chunks that we've stored in the docs dictionary and encode the text. And that's it. We have a structure with all of our chunks, including its context. So again, that context is the source file name in our very simple example, and the vector representation for each of them. Following step 4, we're going to insert the chunks and vectors into the database. So here in this code, we're initially going to use a cursor object from the established database connection to execute a command that truncates the specified table. This operation ensures that all existing rows are removed, effectively resetting the table to an empty state and preparing it for fresh data insertion. We then utilize the cursor.executeMany method to insert all prepared tuples into the table in a single batch operation. This method is highly efficient for handling bulk inserts, significantly reducing the number of database transactions and improving performance. And then, of course, we're going to commit the transaction, which will ensure that all changes are saved and made permanent in the database. And then just to confirm, let's see what's currently stored in our table. At this point, our database contains all of our knowledge base, so we're ready to proceed to the next step, which is vector retrieval and large language model generation. In this lab, we'll go through the steps to integrate the vector database, in our case, the Oracle Database 23 AI, and retrieve a list of text chunks that are close to the question in vector space. Then we'll use the most relevant text chunks to create a large language model prompt and ask the Oracle Generative AI Service to create a nicely worded response for us. Our first step is defining the SQL script that we'll use to retrieve the chunks. In the given SQL query, top K represents the number of top results to retrieve. The query selects the payload column along with the cosine distance between the vector column in the specified table, which is table name, and a provided vector parameter, vector, aliasing the distance calculation as a score. At the bottom of our query, by ordering the results by the calculated score and using fetch approx first, the query efficiently retrieves only the top K results based on their cosine similarity to the provided vector. To start, we'll take a text. This is supposedly the question the user is asking the bot, and transform it into a vector. Following that, we write the retrieval code. We employ the same encoder as in previous text chunks, generating a vector representation of the question. And then we'll add the SQL query, executing with the provided vector parameter, fetching relevant information from the database. For each result, the code retrieves the text content, stored in JSON format, and appends it to a list along with the calculated similarity score. This process iterates through all fetched results, accumulating them in the results list. Now, if we print the results, we're going to get something like the following. So as we requested, we have the score of each hit, which again is the distance in vector space between the question and the text chunk, as well as the metadata JSON embedded in each chunk. Now remember, in this scenario, it's a user asking a chatbot this question, which, if outputting these results, would be kind of an odd response. In a retrieval augmented generation application, or RAG, the prompt given to the large language model is crucial for ensuring that the model generates accurate and contextually relevant responses. So before we send anything to the LLM, we must ensure that our prompt does not exceed the maximum context length of the model. We're planning to use the Llama 2, so the context is limited to 4096 tokens. The truncate string function takes a string and a maximum token count as inputs. It tokenizes the input string, truncates the tokenized sequence to the specified maximum length, and then decodes the truncated tokens back into a string. This function effectively shortens the text to a specified token limit while preserving its readable format. This is useful for tasks requiring length constraints on input text. So in our case, we'll truncate our chunks to 1000 tokens, which will leave plenty of space for the rest of the prompt and answer. Now for our prompt, we want to include the retrieved top chunks, the questions posed by the user, and the custom instructions. With that, all that's left is to call the Generative AI Service large language model. We're going to create a new file called config, and then we're going to right click and open it. We're going to copy the config template from the Live Labs. Now, in order to get this information, you'll need to sign in to your Oracle Cloud Console. Starting with our user OCID, we're going to go to the top right corner, click on it, and go down to user settings. We'll then copy it, go back to our Jupyter lab, and replace this information. To get a key file and fingerprint, we're going to go back to our profile, scroll down, click API keys, add API key. In most cases, you don't need to download the public key. Regardless, I'm going to. From there, click add, and then close. Here, we're going to grab that fingerprint, as well as drag and drop the key file. Right-clicking your key file, you'll go and copy path, and go ahead and add that information. Finally, for tenancy OCID, click on the top right, and then tenancy, and then copy your tenancy OCID. And paste it. From there, go ahead and save the file and jump back to your notebook. Copying the script from the Live Lab, this is going to initialize our OCI client. The only thing we need to go ahead and add is the compartment OCID. So going to the navigation menu, identity and security, compartments. I've already gone ahead and created a compartment I want to use, so I'm going to go ahead and route myself there and copy its OCID. So I've created compartment ADB Gen AI demo. for the purposes of this walkthrough. So copying that OCID, going back to my notebook, pasting it inside of there. Now we'll do the Shift Enter. Now, as no errors have occurred, we're going to add the final bit of code that actually makes the call. So how this code works is it leverages OCI to generate text using a language model, very specifically the cohere command R+ model. The process starts by creating an inference request where various parameters are defined. These parameters include the input prompt, the maximum number of tokens to generate, and settings for controlling the randomness and creativity of the output. Following that, the code sets up the details required for the text generation request. This involves specifying the server mode and model ID, which identifies the language model to use, and the compartment ID where the request will be processed. Finally, the configured text generation request is sent to OCI's Generative AI Inference client. The client processes the request and returns a response containing the generated text. So if everything goes well, there you can see the responses to a number of questions the user has asked the chatbot. With that, that concludes our Build an AI chatbot engine with Oracle Database 23 AI and OCI Generative AI Services, Day 1 and Beyond hands-on demo. Thank you so much for taking the time.